Okay, welcome back everybody. CJ here, your local friendly technology addict, and you're still watching the Tech Addict's Attic. Not sure why, but you are. So there must be something good here, right? So I said earlier that I got about a quarter of the way into this before I had to put it down. And looking at it, I think, well, actually maybe that's about right. I keep going back and forth, changing my mind and whatnot. But it's not the number of components you have to worry about, it's the number of solder points. But what do we have here? I've got a resistor that's 100. That would be brown, black, brown, I believe. Uh-oh. I just noticed I've got this oddball resistor that's blue. I thought I had already put in all of my... I have. Uh-oh. So now I gotta compare them all. However, this one is different. So the other three that I had were brown, brown, black, black, red. Brown, brown, black, black, red. Brown, brown, black, black, red. Okay, so I do have the 2K resistors correct. This one's brown, black, 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 brown. I'm going to assume I've got one of those, and I need exactly that many 100 ohm resistors. So, by process of elimination, this must be 100 ohms. Keeping in mind I'm on a 20 kiloohm scale, that makes that 100 ohms. 0.1 kiloohms. Come on, get on there. Man, that's right, smack dab on it too. Or at least it was before I moved. Okay, so this is the 100 ohm resistor. And since it is symmetrically palindromatic on its color scheme, it doesn't matter which direction I put it. Doesn't matter anyway, being a resistor, of course. However, I am trying to be consistent with my scheme. There, I got that one in. If I can get them both in at the same time, that would be nice. Alright, so that one's there. Now I have two 10K ohm, and they both go right here in the middle. I really need to push this a little further away from me if I'm going to continue doing this way. And my scheme for the vertically arranged ones is to have the tolerance band on the top, okay. Come on. Come on, you little twerp. Okay, I now have my two 10Ks installed. Not soldered yet, but they are installed. You know what? Let me go ahead and get this one. I think this is my 47K. No, I've already done the 47K. What is this? Green, blue, red. If I recall correctly, green is 5. That would make blue be 6. And red is 2. So this is a 5.6K ohm. So I should find in here somewhere a 5.6K. And looky, right there. 5.6K. How do you like that? If you are not familiar with the color codes used on resistors, at least here in the United States, I don't know about the rest of the world. I don't know if it's an international standard or not. But if you're not familiar with it, I like to remember that black is 0, brown is 1. And then it's red, orange, yellow, green, blue, indigo, violet. Well, there's no indigo, but blue, violet. So 0 and 1 are black and brown. Red is 2, and then it's 3, 4, 5, 6, 7, so forth. You don't have to worry about slate or gold or silver until you get into the really fancy ones, and I don't think I've ever even seen one that wasn't professionally, commercially soldered onto a board. And even those, if I've ever come across one of that color scheme, I don't remember it ever happening. But you just have to remember that the first 2 bands are your significant digits, your values. And then you have the 3rd band, which is your multiplier. That is simply the number of zeros you tack onto the number that you've already gotten. So you'll have 2 digits and then the number of zeros that follow those 2 digits. And then you have your tolerance band, which is either gold or silver, or there's a couple of other oddballs, but I've never seen them. Which of course mean different things. One of them means 5%, one of them means 10%. I believe that there is also a 2% and a 1%, but I don't really recall right off the top of my head. And in addition, if you need resistors to be that precise, you already know about all of that, and you wouldn't be watching my channel because you would be making your own channels. So, alright, I've got all my 100K ohm resistors. I've got my 56K ohm resistor, or 5.6, whatever it was. I've got the 100 ohm. In fact, all of my resistors, except for this one variable one, are done. Ooh, and you know something? This board doesn't match the picture. Because on the picture, this resistor was horizontal, but here it's vertical, and I don't know if it goes vertical one way or vertical the other way. I don't know if it even matters. Being that it's a variable, it really shouldn't. It just, do I turn it clockwise or counterclockwise? But I'm going to go ahead and solder all of these on. Shouldn't take but a moment. In fact, you know what? I've been using the tiny solder, and that stuff is my dad's. I really don't want to waste it. I want to try the big stuff for just a moment and see how well it does. That was an exhale as I went through the fumes of the solder. You know, that's something else. That's something that bugs me. You get people who are so... I don't want to be offensive, but they're so, let's just say, cautious about certain things. One of them being solder fumes, and like, well, you gotta have this protective gear, and you gotta have that protective gear, and blah blah yada. You know what? I've been doing this long enough. I'm not crazy yet. And by the way, I have held sticks of solder in my mouth. It's not going to kill you. It's not going to make you go crazy. What it does requires you to ingest it. Have it go through your system. Or have constant contact with it. Constantly handling it with your bare hands, and your skin can absorb it. Now, how much of my solder do you see me handling with my bare hands? Not a lot. Yes, I'm doing it, but it's quick, it's short, it may be semi-repetitive, but it's not going to kill me, it's not going to make me crazy. Because, as my wife has said, it already has, right? Alright. A few more to go. This is actually working alright. I prefer the tiny solder for this, simply because this solder is about the same diameter. Well, not the same diameter as my iron, but it's a good size enough diameter that the iron tip is actually in the way with it. So what happens is I try to get the solder onto the contacts, the little solder pad on the board, on the PCB, and instead I'm getting it on the tip of my iron. So yeah, I do kind of prefer the tiny solder, because the tiny solder is small enough that I can actually get it just on the pad of the PCB, or just on the lead of the component if I want. The downside is it's a little harder to see. Now, those of you who do not know how to solder, doesn't take much. You basically want the tip of the iron, well, first off, it's got to be fully hot. You want the tip of the iron touching the item that you want to solder and the item you want to solder it to at the same time. At least that's how I do it. Now, some people only do it on the solder pad of the board. I don't think that that's proper. I think that you'll wind up with a cold solder joint, because the lead of the component does not heat up properly for the flux and the solder to adhere to it properly. You may wind up with a spot where there's more flux on the metal than solder, or on the lead, and you'll wind up with a high resistance connection. So what I do is I try to get the tip of the solder to touch both the lead and the pad at the same time. Heat them both up at the same time, and then the solder flows evenly between the two. And it's very similar to surface tension with water. It will, once it touches the thing, it'll spread out, it'll flow on it. And you don't have to move your solder around the entire contact. You just get it on the very tip, and it'll touch what it needs to touch. It'll spread out. It'll do what it needs to do. Alright, so U3 LM393. That's this guy here. I have a choice, and I'm going to do it. And that choice is whether or not I use a socket. There's really no reason for me to need a socket on this, because I'm not going to be needing to remove this chip. Am I? Well, now that's a good question when you think about it, because well, maybe the chip fries itself. And I need to replace it one day. Now, I've got to set this down in order to solder it, of course. Not having the right equipment, although there is something here I could do, I'm just going to use the coil, the inductor here, and all of my switches pushed in so that it will rest on the socket. Once I get 2 pins soldered, now I'm having difficulty on this one because I didn't have my angle right. Much better. Once I get the 2 pins soldered, though, I don't need that anymore, and then I can avoid the risk of melting it. It did not sit flush against the board, so I'm trying to quickly heat it up. I'll use one of these. This is where having the proper tooling and the proper equipment comes in real handy. Thing is I don't do this often enough to warrant the cost of a $300 soldering station. Yeah, I can't talk tonight. Yeah, it's all the lead, as my wife says. It's, you know, I'm so crazy I can't talk straight because my, see, and look at that, I'm sitting here, I've not even done soldering the thing yet. It's because I eat this stuff all the time, right? I breathe the fumes all day long. But no, I can't warrant spending $300 on a proper soldering station with, you know, built-in fume extractors and solder feeders and, you know, hot air rework and all this other fun stuff that, trust me, I wouldn't mind getting into. I wouldn't mind learning a few new tricks, even if I am something of an old dog. Alright, so that one's done. I'm going to go ahead and do this one next. Alright. And again, I think this time I'm going to try. Oh, where is it? Oh, I'm using it. Okay, I'll just use this one. Won't work. One of these, perhaps. Yeah, maybe if I do it from the underside. So anyway, yeah, that's not going to do it. I make do with what I've got a lot, and usually it's okay, but there are times when you don't want to do that. Forceps, these will work. There we go. It's late in the day, my hands are getting tired, and you know, all that lead that I have ingested. But I'm going to go ahead and pause the video while I finish this up. I've got a lot of little things, and you guys don't really need to see, so let's see how far I get. So, on this socket, or in this socket, I need to have, as we've already seen, the resistor pack, or whatever that is, a 09. But this capacitor here, capacitor 6, 10 microfarad, of course if I leave it vertical it's not going to clear the underside of the chip even with the socket on it. So with the socket there I'm going to need, even with the socket there I'm going to need to bend that capacitor down. With it bent down, messing with the leads to make them stay, it just doesn't feel quite right. So here's another technique that I do from time to time, holding it with my hand. I'll just let the solder be stationary. And move the entire piece, iron and all, to meet the solder. This method does work, at least for me. And allows you to keep your hand on the part, on the component, keep the component in place where you want it without having to worry about it shifting. Ah, crap. Well, just lost a piece of a lead inside of my keyboard. Oh well. That's why I shouldn't be doing this on my computer desk. One of many reasons. Okay. Pausing again. So something has just occurred to me, and unfortunately I've already soldered all of them onto the board, but the electrolytic capacitors have a polarity to them, and it's a pretty obvious thing on the board, and you can probably still see it. You can see it if I can get this to focus up close, right up in here. There we go. You can see on the bottom half of that little circle that it is shaded. The shaded part on this particular board is the negative, and you'll see on the side of the capacitor it is marked with a stripe with an outline of the negative symbol, the minus sign. Similar to this one. It's striped with a black minus sign on it. Same with these two. You just make sure that that negative sign is on the side that has the marking for being negative, and on these they also have the non-shaded side marked with a positive on the board, a plus symbol. And that's not a big deal. I mean, it is. You got to make sure you put them on right. But you'll notice over here on the diode side that it's almost easy to misread. You'll notice on the left-hand side of each one of these diode markings that there is a line on the end, and that line corresponds, I can never remember if it's anode or cathode, but it corresponds to the stripe on the diode. If I can get my phone to focus. Come on. I really need better equipment. There we go. So you'll notice one end of the diode is painted silver. That's the negative. In order for electricity to flow through it, that negative has to be facing the negative side of the battery. That or negative charge, if it's AC, it'll rectify through that using that on the negative side. So just make sure when you're putting your parts together that you observe the correct polarity, assuming that you are, putting a kit like this together for the first time. Maybe you've never soldered anything before. That is something to keep track of, is the polarity of it. And I noticed this thing down here, D13. For a moment I thought it was a capacitor because it's circular and it's got a positive and a negative, about the same size as the little tiny 10 microfarads here. But then I saw the 470 microfarad. I'm like, wait a minute, that 470 is pretty big. And then I realized that's the 470, though. That's a diode. And it's clearly marked a D13. But I'm I'm like, well, wait, I've only got 4 diodes, and they all go. Then I realize, oh, no, 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 no. It's an LED, light emitting diode. So I've got to put that one there. But we're coming along. Just got the inductor, transistor, or excuse me, not a transistor, that's linear voltage regulator, 5-volt regulator. I've got a resistor, 10K to do over here. And why is there an extra? Interesting. I'll figure that one out soon enough. 4 diodes, 5 diodes if you count the LED, the resistor, the variable in the middle there. I'm almost done. Alright people, I'm an idiot. I'm sitting here looking at this right here. 10K R10 and it's got 3 pins on it. I'm sitting here thinking I'm going to be putting in a carbon film resistor. No, I'm like I said, I'm an idiot. It's the variable. It's a potentiometer here. You know, this is me being stupid. Alright, so I am a little bit confused. As is prone to happen from time to time. It's obvious to me, though, that this piece here goes on the underside of this piece here. And then, of course, all of these get soldered. And this, probably in combination with the standoffs, will mount here. Now, it's also obvious to me that I'm going to have to use some of this right here to increase the distance. Well, not even that. It's a mounting point. It's a connector. But it would also increase the distance of this piece to here to clear that capacitor. What confuses me is why they gave me so much of this stuff. And of course, there are 2 transistors left over, and I can't decide if they're there to prove that the thing works. You plug the transistor in and test it, although this isn't a transistor tester. This is an LCR meter. Or is it a transistor tester? Good question. So anyway, I don't know if those are there as spares in case the ones that are, you know, soldered in have somehow failed, or if they're there as examples, like here, test these, we know they're good. But I don't understand why they would give me so much of this stuff here unless it's just easier to give whatever shavings are on the factory floor. The other thing that I'm a little bit concerned about, and yes, I'm aware I haven't put my inductor in yet, and I haven't put my chip in yet. But the other thing that I'm a little concerned about is this voltage regulator not being marked. Pin 1 is in the middle, if I can read that correctly. That's not a 1. But the thing is I don't know if I need to put the back side against the PC board or the front side against the PC board. Because normally I would be looking at a heatsink of some sort on the back side of a voltage regulator. and yet I don't have that here. I've got pin 1 marked on the board, but none of the pins here have any kind of marking indicating which one is 1. I believe that this is the correct orientation, but I'm not positive. So before I solder that one in, I'm going to go do some quick research. But before I do that, I'm going to go ahead and finish the rest of the project. So something else that I've noticed, on these larger pads that are on the display, I wound up going to the larger solder because it will melt against the iron tip and the pad at the same time more quickly and readily than the tiny solder will, because the tiny solder is so small. When it starts melting, it basically just covers the pad and it doesn't have enough volume to contact the pin or the lead and thereby create the meniscus that you get between the lead and the pad with the larger solder. So you wind up holding the iron on it too long and you'll overheat the component. Secondly, on this board, clearly there are resistors that have been surface mount soldered to the board, but none of the capacitors have been. And there's also a little microchip on the back side that's missing. I don't know if this is a big deal or not. I don't think that it is, because I know that a lot of parts are multi-purpose and multi-design. They go with different circuits, different schematics. I'm just checking my work here. I'm not happy with all of it, but I'm trying to get it done quickly. And it's good enough. I can see that the solder will work. I've got a good connection on them, so it's not a big deal. I'm going to go ahead and ground myself again, and then I'm going to handle these components. Now what I don't know is what this pin header is for. It has 10 pins on it, so I'm wondering if it doesn't have an adapter to a 9-pin serial RS-232 style connection, or excuse me, protocol. Trying to insert the chip without breaking anything, because the pins are spread out just a little bit farther than the socket is designed, so you have to kind of put one side of pins in and then kind of squeeze the entire thing down into place on the other side. And this thing has that old 1980s feel. Like it's not that smooth plastic that you find today, ceramics and whatnot. No, this feels like 1980s circuits, ICs. And again, make sure that you keep your pin 1 orientation correct. Only 2 components left. Okay. We're almost there, people. I want to take a swing and guess on this. On a chip like this, it's usually pin 1, 2, 3, left to right when you're looking at it in that orientation. And without having the schematic of the voltage regulator in my hands to look at, I can't really say, but pin 1 should be that square on the right over here, and pin 1, I don't see a trace coming off of pin 1. Wait, yeah I do. Pin 1 is going to the positive of this capacitor. Pin 2 in the middle appears to be going to the negative of this capacitor, and pin 3 is going over here to the switch, as well as, I don't know, somewhere under these resistors it turns, and I don't know if it goes north or south at that point, but that's probably the output. Yeah, I'm going to do some quick research. Let me pause the video while I do, because I don't want to risk frying this thing. Okay, so I have figured it out. On this image, you can see that I did actually have that that resistor turned around 180, so I fixed that, and you can see here that the 7805 does go with the backside against the circuit board. So, that all said, right off of the bat, I'm annoyed by this. The capacitors underneath were bumping against the housing for the screen for the little LCD readout. So I wound up flattening that up against the circuit board to the best of my ability. And even still, it does not properly seat fully on the pin header and do so flatly. Even if that were not a problem there, I'd still have the same problem over here where this other capacitor is. That's just poor design. They know the dimensions of these parts. They can easily design that where it will actually fit. And of course on their image they don't show the standoffs there, they show them on the the board itself, which, you know, this doesn't really need them. I just figured it would be a nice touch to provide a little bit of stability to it, you know, seeing that it's on these little stalks of connector things. But neither here nor there. It's starting to get late and I can tell that I'm starting to ramble on. So I'm going to try to finish this up real quick like. I've got all the components on that will fit. There are 2 transistors and a pin header strip that are apparently extra. And of course I've got a couple more of these to put on. These caps for the switches, the little red push button caps, those just push right on. There's nothing to them. And there we have the completed kit. Only took me a couple of hours, start to finish, if you don't count the time in between when I had to put it aside while I went and took care of other business. I'm done with the soldering iron. So I'll unplug it so I don't forget. Now I just need some kind of a power source. I would like to do something other than 12 volt DC because I already see that it's a 7805, so I know that it's designed to run off of 5 volts. But I'm going to do some quick looking and see if I can find out on their website if there's a document that tells me exactly what power level to use, because I really don't want to guess at this. Something else that I've noticed, the image that I showed on this video is the kit that I've got. But there are other images in that same item on eBay that are not the same exact kit. Small little things are different. For instance, on the main image of this kit on eBay, where I bought it from, these are not blue, they are green. And the board is not blue, it is green. That's not a big deal, I really don't care about that. What I do care about, however, is the fact that this resistor is oriented differently. This chip is hiding somewhere else, I think up and around this area. The whole board is a little bit narrower from top to bottom. And I just, I don't know. Oh, also there's markings on the circuit board on the main image that are not on this board. Look, for instance, this is marked as a capacitor, this is marked as an inductor, and this is marked as what looks like a square wave or a pulse wave. I guess that's FX's frequency. So apparently it'll read frequency too. That's new. Oh, it's an FLC tester, frequency, inductance, and capacitance, I guess. So while they're in the same spot, they're marked a little bit differently, and it just throws me off a little bit. Looking at it again, this one looks like it's a capacitor. Maybe this is an electrolytic capacitor? It's hard to say because the image is, well, you know how they do. They take the lowest resolution thing they can find. And I'm looking at the other images, and they do show it's pretty clear. They do show very clearly the component orientation, or at least the important bits. This is the kit that is shown on the main image, same as this one, same kit. But in fact, all three of these are the same board. But the one I've got is this one here. Same as this one here. So I am still going to see if I can find some indication of there being any kind of documentation on this thing. New, brand new, unused, unopened. I hate the way eBay does their descriptions now. So I'm assuming that this pin here, or this pin header, is for programming the chip underneath the screen. But again, I see no indication of that. I see no indication of documentation. Frequency meter, inductance, capacitance. Yeah, it's for frequency. Frequency range is 20 Hertz to 400 kilohertz. Says small signal can be measured. I guess they mean under 1 volt, but I don't know what they define as a small signal. Supply voltage, DC 5 volt or DC 8 to 14 volt or AC 7 to 10 volt are available. Okay, So let me go and grab a random power brick and see what I can do. Oh, hey, look. I happen to have one. 12 volt DC, 1.2 amp, pin positive. Oh, hey, and it fits. You gotta love that. So I'm gonna plug it in first. Oh man, this thing's heavy. It's making my power strip fall over. Here we go. No, I'm not going to do it here. You guys have gone through this video so long, it would be a shame for me not to test it, right? Stay tuned for the next video. I'll do that in a second video. This is the completed board, and we'll do the first power up in a video all on its own. I think it's deserving of that. So until then, just keep your eyes open and you'll see it go up when I make it public. Thanks for watching, and stay tuned. This is CJ, your local friendly technology addict, signing off for now.